All right, we are making progress. We have only one left, and it is, I don't want to say it's the big one. I mean, multiplication had something to it, but division is certainly last for a reason. So now we want to follow a similar approach, keeping things as basic and intuitive in our understanding and our explanation. And if I want to understand what the simple, basic, introductory level meaning of division is, let's just take integers. Let's just take familiar things like 100 divided by 5. Nice numbers, easy to work with. At this stage, I wouldn't come to fractions if I can't do this already. But now I have to put this in words. So my question is, what sort of word problem, what setup could result in this calculation? So that instead of the calculation, I can say instructions in words that is equivalent to this. One is, let's say we have 100 people. There's more than one way to interpret this. I'm going to go with the one that I find works the best moving into fractions. I have 100 people. Let's suppose they were instructed to where they come in groups of 5. Let's say groups of 5. Let's say every 5 people, they come in a group, whether it's a family or someone else. They register in groups of 5. They all have the same color shirt on, and every group has a different color so that they can be recognized. Regardless, they come in groups of 5. So as I look at the 100 people, they might be walking around and be mixed up, but I know that if I see red shirts, there are 5 red shirts. There are 5 blue shirts. There are 5 green shirts. There are groups of 5 everywhere. Then I could ask a couple of questions. One question is, how many groups are there? And the calculation to determine that is exactly 100 divided by 5. I can also ask a different question that results in the same calculation. If I have to sort of hand out the shirts, I'm going to have to know how many colors I need to make. I need to be prepared before the people show up. I'm going to have 100 people. I want them to be groups of 5. So I'm going to have to get ready with my shirts so that every group gets a different color shirt. I need to know how many colors, how many groups. But I can phrase it in a different way. I can say, how many times can 5 fit into 100? I have these groups of 5. How many times will I be able to fit a group into the 100? That's exactly the same. These are exactly the same. Or not, I guess in words they're not the same, but they are equivalent in concept and in the resulting calculation. Okay. Now for fractions, I find that the second one is just a touch better on the intuitive level for me, but I have to be okay here first with the fact that these two are the same question. They'll always have the same answer, and it'll always be the division answer. So with division, there can be variations in the wording for the exact same calculation, making it a little bit more confusing potentially, especially if I don't vary my words enough to get students, when it comes to integer division, to get them to be comfortable with variations in the words, all corresponding to division. By the time they get to fractions, I want to be able to switch and rephrase this to something that works for me. Now, the second one, for me personally, feels still a little bit more natural when I get to fractions, but when it comes to integers, I really don't care. I need to be happy with all of them, of course. So now, what does this mean? This means the first number in my division is what I start with. That's what I have. Remember, in multiplication, the second number was the quantity that I have to start with and that I applied some instructions on. Now the first one is what I have. And then the second number is my group size, if you will. It's the size of a group. And then the division tells me to fit in that group size into what I have and count how many times I can do that. Okay. So now when we move on to fractions, nothing's going to change. The meaning of the instructions on an intuitive level will be the same. So let's go and find an example to do that. Division, division. There we go. 14/9. Of course, we'll do one example today and finish it up tomorrow, but we can at least start. 14.9, and then you can sort of just let it sit in the back of your mind, and then we'll confirm that understanding tomorrow. What I have is, it doesn't really matter what that first one is, we'll see. Actually, it doesn't matter what any one of them is, but for a first example, let's take a couple of proper fractions. They're easy to draw, easy to work with, just easy all around. Okay, now remember, I have the first quantity, regardless of what it is. So let's draw that. I want to make it nice and big. Let's make it nice and big. I have to split it up into 6 slices. Here I definitely want to give myself some space because it's my first example and I'm not used to it yet. And I know that I have 5 of these slices. 5 of them. Almost dipped into the 6th one. Nope. I don't have it. Okay, so that's what I have to start with. So now, my group size is 1/4 of a whole rectangle. There's nothing following this 1/4. It's in reference to a whole. So I need to figure out what on earth is this. That is why I'm going to go horizontally in 4 pieces. So that I can make sense of this because, let's clarify that, that's 1 of 4 rows. Because I've used columns, I can use rows for the interpretation of this fraction. So I'm going to go half of half. And this is where people struggle a little bit to separate the different methods from each other, because this that I'm doing now is in reference to a whole rectangle. So for the immediate future, there is no pink. Pink is something I look at when I do the division instruction. And right now, I'm only trying to understand what that second number is. I haven't gotten to the division yet. So I haven't gotten to the pink yet. And people struggle to look at this rectangle without seeing pink. If that is the case, then go and draw it somewhere else. Copy it somewhere else so that I can see 1 in 4 rows that corresponds to 1, 2, 3, 4, 5, 6 pieces. Those pieces are not pink. They're pieces in a standard rectangle split up in 6 and 4 slices. So this is my group size. 6 pieces. Instead of our, no, not that one. Instead of our basic example with the shirts and the people, that came in a group of 5. Now we have a group of 6. Now we're not going to do it exactly the same as the people, in the sense that I'm not going to do an integer division in the same way as I'm doing 100 divided by 5. You could, but in an attempt to try and stay as far left as possible, I think there's an even simpler, more basic approach here. By simply going and looking at what I have and making groups of 6. I'll use blue so it's easy to spot. So let's make a group of 6. There is one group of 6 I can make. Or I can say 6 can fit in 1 time so far. 6 can fit in, that's 2, 3, maybe like this. It really doesn't matter, right? As long as I cover, or as long as I fit in as much as I can. Or fit in the group size as many times as I can, rather. And then here I can fit it in. And your blue part might look a little different. Doesn't matter. And I have 2 left. I don't have enough for another group to fit in completely. Okay, and that's a little visually much nicer as well. And if I can do something visually instead of sort of with a cold 100 divided by 5 calculation, it's going to be better. It's going to come across much more intuitive and natural feeling. So now let's write some sentences here. We can fit the group into, I'll write that in pink to emphasize it, into what we have. We can do that 3 whole times with 2 pieces left over. Yeah, those pieces are pink, sure. Sure, we can make them pink. Okay. Now the fraction calculation here doesn't actually matter right now, right? We've converted things to an integer calculation. We've gone even further to the basic side by not saying, what is this, 1, 2, 3, 4 times 5? Not saying 20 divided by 6 is 3 remainder 2. I'm going even more natural, more intuitive than that. Though it does depend on your audience, you can take that route as well. But with the goal of what we're trying to do here in mind, I think if I can do things visually and as basic as possible, that's going to be even better and easier to understand. So I don't even rely on integer division. It's even more basic than that. Okay, so I'm fitting in my groups because that's what division tells me to do. I can do it 3 whole times and 2 little pieces are going to be left over. Now I have to write my answer back in fraction form. And this is where things are a little different than the other ones. Previously, when I think about addition, I had portions of a whole, assuming now they're just the proper fractions. Portions of a whole, put them together, I get some portion of a whole. Maybe a lot more, but something like that. So my answer for the addition question is in reference to a standard whole rectangle, just like the originals were. Same for subtraction. I start with portions of a rectangle. I have a removal instruction, but I end up with portions of a rectangle. So my answer and my original fractions are in reference to the same kind of thing. Multiplication. Do we have a multiplication? Sure. Let's just look at this simpler version on the right, because multiplication is a little different. I have some portions of a rectangle, regardless of how much. I have to take some portion of that portion. So I'm ending up with portions of a rectangle. So again, my answer is the same kind of answer, same kind of meaning as what I started out with. But for division, it's not. For division, it's not. For division, I start with, man, what's this stupid line doing there? My hand clearly shows, drag it down, thank you. For division, I start with a portion of a rectangle, right? But because of the instructions of having to count how many times I can fit something else in, the answer isn't a portion of a rectangle. The answer is a number of times I was able to do what the instructions tells me to do. So how should I write this here? Let's say here, the answer is, let's say here, a number of times I'm able to do what they tell me to do, not a portion of a rectangle. So because the instruction is different when it comes to division intuitively, the answer sort of, I don't want to say the units of the answer, but in a way, the unit of the answer and the unit of what I started with, they're not the same. I was doing something completely different. So here, it's a number of times that I'm trying to represent in fraction form. Yeah, not confusing at all, right? So my answer, let's just say it like this. My answer is, of course, going to be 3 whole times. And then I can do this fitting in instruction, not another whole time, but another, I can fit in another 2 of the 6 that I need. So 2/6 of a time, or 2/6 of a group, I can fit in after my 3. So that is my answer. I can do what they say. Let's try and zoom out and see the whole thing. Sort of. I can do what they say I should do, this fitting in procedure, 3 whole times, and then another portion of a time, so to speak. Or how many, or you can rephrase it, how many groups of size 6 can fit into what I have? 3 groups completely can fit, and then another 2/6 of a group. So I do have some flexibility in terms of how I want to phrase it that makes the most sense for me. But it's all connected to my understanding that's already established when it comes to integer division. Group size, how many groups can fit, or how many times can I fit a group of a specific size? Those things are equivalent when it comes to the intuitive understanding of division. I'm doing the same thing. I just have to sort of convert these fractions to integers in a way, definitely the group size. And for what I have, I didn't even bother writing that as 20 and doing division. I'm just doing a manual basic, fitting in the groups, visually seeing it one by one, it's even better, even easier to understand. And then I just have to get to grips with what my answer is saying and what kind of answer is this in reference to. It's a number of times it can fit, or the number of groups that can fit according to the instructions. So obviously, we need more practice. We will have more practice tomorrow. Zoom out a little bit. There we go. So we did the first division example. We have to definitely have some mixed numbers. But let's start with number 2. Actually, number 2 is a tough one too. Let's start with number 3. I don't think we should really be cheap in this one. Oh, hold on. I think we should do them all because division is tough. Hold on, my tablet is on the wrong screen. 1 second. Work area, switch. There we go. With division, yes, it's luckily not like multiplication where there are sort of 2 versions, but some people get a little flustered when, no, I said not 2 first. I will do 2. We have to do 2. Some people get a little flustered when they see different size numbers in the division. Sometimes the first is bigger, sometimes the second one is bigger, and it feels, maybe coming from multiplication, that they should do something differently. That's not the case here. Luckily, there's only one way of doing this, depending on, of course, the exact sentences that you're writing. So we have an amount. Remember now the first number in this division instruction is how much I have. So I have quite a bit. So that's nice. It's definitely more intuitive to see a substantial amount that I can work with. So let's draw that. Don't want to make them too small. Don't want to make them too big, but enough so you will have space to draw and fit stuff in. So I'm gonna, of course, realize that. Ooh, that was nice. That's a nice pink. It's a nice pink. I have the whole first 2 whole rectangles. So at this stage, I see no need to break them up. Of course, with enough experience, having done some examples, I know I'm going to have to. But in the case of addition, I didn't. So it really depends. Definitely splitting up the last one into 4 slices. And then 1 of those slices is what I have. Okay, great. That's quite a bit. Nice. I like it. Now we have our group, or group size is 2/3 of a whole rectangle. Not of what we have, just group size. So I need to figure out, well, what is this? How many pieces am I looking at here? So for that reason, I need to bring in this denominator as well. So 3 slices horizontally. No, that's not going to be in the middle. Like so. Because I just need to see a rectangle. This has got nothing to do with pink. I just need a standard rectangle split up in this way. so that I can see, well, 2/3 means 2 of 3 rows. That means my group consists of 1, 2, 3, 4, 5, 6, 7, 8 pieces. Those pieces aren't pink, they're just pieces. So that's going to be my group size. Now when I look at what the instructions want me to do with that group size, which is fitting it into the pink, now it matters what I actually have. Now because I'm going to see how many times can 8 pieces fit into the pink that I have, I of course need to split the others up as well. So everything needs to look the same. I need to see those pieces everywhere. So for that reason, I do have to split the first 2 rectangles. So let's do that. Let's do that. Try and make them equal, sort of. And then horizontally. The more I have, the more lines I have to draw. There we go. Okay, now I'm ready to do my fitting. So let's get fitting. Now again, you can take sort of the lazy approach and say, just count how many pink pieces I have, divide that by 8, and then, like usual, I convert my fraction calculation to an integer calculation. It's not wrong, but it feels a little detached. And with the goal of going as intuitive and basic as possible, I have a drawing. Why not go all the way? 8. I can fit 8 in here, like so. That's once. Then I have 4 over here. And let me make it T. That would be 8. That's another time I can fit them in. Doesn't matter how. 2, 4, 6, 8 over here. That'll be 3 times. And then I don't have enough left, right? I do have some left, not enough. Okay, so let's write that down. So color is always going to be better. Drawing is always going to be nicer at this level. So blue, well, in a way, sure. We can fit our groups, our group size, however you want to say it, into what we have 3 whole times with 3 pieces left over. And of course, if you did, how many squares did I have? I don't even know. 1, 2, 3 rows. 1, 2, 3, 4, 8, 9. So 27. 27 divided by 8 is 3 with a remainder of 3. But I think this is nicer. Okay, so my answer therefore is going to be, not pink. My answer is therefore going to be, I can follow the instructions, doing this fitting in of groups 3 times with 3/8 of a group that I can account for, or 3/8 of a time more, however you want to say it. That is my answer. And we are done. So when it comes to the division presentation, it's actually, there's more thinking, more understanding involved, that if I didn't think about this beforehand, I wouldn't know what to do. But in terms of the sentences that I write, it's actually less. I'm a little disappointed now. Because my reference denominator, so to speak, is already done. It's the group size. I don't need a standard sentence like I have in the past, because my answer isn't in reference to a standard rectangle. So it's a different kind of concept. So I actually write very little. So definitely don't go cheap on the writing, but make sure that we show what we have. A lot of what we did is in diagram form, so that cuts out some sentences. Then I write down the results of our fitting in, and that leads me directly to the answer. So it's a little short in the presentation, but still we didn't skip any step, making the jump too big. The drawing is a bigger part of it than usual, and I think that's maybe the reason. All right. See it all. So the most intuitive one, okay, so we see that the first number can be a mixed number, it can be large, it can be small, whatever. It's about the second one, fitting that in to what I have. However, it does to some people feel a little strange if I have a very small first number. So let's have a look. I'll now go back to number 2. Number 2 is 1/5 divided by 2/3. Now, yes, the second number can be big. We'll make it big later in number 4, but it's bigger than the first one. Doesn't change what I do. I still have my first number's quantity. It's just not a lot. Not a lot. Split it up into 5 slices. Sort of equal. I don't think I did a very good job in making them equal. My last ones are always a little bigger. And we only have one of those slices. So sad. Not nothing, but it's not much. All right. So now, understanding what the division is instructing me to do, I need to look at group size of 2/3 of a whole rectangle. Let's emphasize rectangle. That means 2 of 3 rows. Oh, it's 2/3 again. Oh, I'm sorry. That's not very original, but we're already in it. So I split it up so that I can see, I need to see 2 of 3 things. Columns are done, rows it is. So that means that my group size in integer form is 1, 2, 3, 4, 5, 10. 10 little pieces. All right. Now the instructions tell me to fit a group of 10 as many times as I can into what I have. We can fit groups, let's say, of 10 pieces into, I'll emphasize, what we have 0 times. No whole times, if you will. With 3 pink pieces. I'm loving this pink. It's not as bright, it's nice. Left over. Left over. So it bothers people perhaps that I can't even fit it in once. I really want to. And yes, this is not the intuitive, well, this is not the example I would start with to build a number sense. I'd like to actually accomplish some fitting in, but this could definitely happen. So that's all we can do. My answer is therefore, I'm not going to write the 0 in the mixed number. I couldn't fit it in at all. I just have left 3/10 of a group, and that is it. So how much of the group can I fit in? 3/10 of it. I have 3, but I need 10. And it's because I didn't have enough to start with. 2/3 can't fit into that. So how much of it can fit in? It's not obvious to me. We draw a picture and try and figure it out. 3/10, it turns out. So this one does feel a little bit strange, and I don't want to do these for my first examples, but they can definitely happen. What feels even worse, perhaps, is when the first number is smaller and the second one is even bigger. So let's see what could be, I think, the worst case. 7/8 divided by 1 2/3. But nothing changes. I have an amount corresponding to the first quantity, 7/8. I'll split it up according to 8s. Half and half. Half. No, not like that. Half of a half. Oh, that half's a little small. Of a half. Of a half. And you quickly see why I don't really want to go past 8. I don't think we have any problems going past 8 either. Luckily, I have a fair bit of it. 7 of the 8 slices. It won't be enough. But I don't know that at this stage. Okay, I seem to have some, so we're feeling optimistic. Now, our group size is 1 2/3 of a whole rectangle. Of a whole rectangle. This is a little different than what I have before. So in order for me to figure out how much this is, I need to see more than just one rectangle. I don't have that many because the first number wasn't big enough to justify it. But the second one is. So it's not going to be pink, but I need to see another rectangle. To make sense of how much is this group size? Oh, it's a lot. So I'm going to have to go 8s and just set it up. Not annoying at all. So because the numbers are a little bit out of whack, it feels as to many people that I need to do something different. And if I haven't thought about this to realize it's exactly the same, I might not know what to do. Okay, it's not going to be pink. I just need to set up another rectangle because the group size is one whole rectangle and then another 2/3 of a rectangle. But same as before, I need to split it up sideways into 3, right? So let's do that. Thirds. Here we go. Here we go. And there we are. So now I can see, okay, this means one whole rectangle has 3 rows, and then 2/3 of another one, that's 5 of the rows. That is a whole bunch. 5 rows. Each row contains 8, right? So we have a group size of 40 pieces. 40. That doesn't seem right, but it is. It is correct, and it's because that second number is so big. So now, the instructions are telling me to see how many times I can fit a group of 40 pieces into what I have. Let's at least write that down. We can fit groups of, my F is always a little not curly, 40 pieces into, emphasize, what we have. Well, as I suspected originally, no, my group size is too big. I don't have enough. You can double check. I have a row here of 7 pink ones. 3 times 7 is only 21, right? So no whole times, just to emphasize, with all 21 left over. And those 21 are pink. 21 left over. Left over, as I suspected. So, the question is simply then, what is my answer for the number of times I can do this fitting in, or how many times I can fit a group in, how many groups can fit in, or whatever wording you want to use. I can fit in 21/40ths of a group. Can't even get a whole group in. I can get a little portion of a group. Approximately half, but it's not exactly half. And that is it. When you understand what the division is asking, and you have figured out how you want to lay out your answer, it doesn't matter what the sizes are that you're working with. It doesn't matter. The fitting in is the same. It's just a matter of doing enough to clearly show that you understand what the instructions are, and then just doing it and understanding there's no difference in the method based on the sizes of the numbers, only for multiplication. There's a little bit of an intuitive difference, I'll call it. Intuitive difference.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.